Hello, so in this video, we're going to look at differentiating the trigonometric function sine. So in this video, we want to differentiate sine of x with respect to x. And again, to do this, we're going to, like the previous video, we're going to use the definition of differentiation from first principles to do this. So if we remember, it's given by this formula. So the derivative of a function is defined as the limit as h goes to 0 of f of x plus h subtract f of x, all divided by h. So using this definition, we're going to try and differentiate sine of x. So if we let f of x be sine of x, then we know that f of x plus h is going to be sine of x plus h, just by substituting in the x plus h. And then now we can use our definition to find the limit, the derivative. So the derivative of sine is the limit as h goes to 0 of f of x plus h, but we know that that is sine of x plus h, subtract f of x, but we know that that's sine of x, and then all divided by h. So that's our derivative. But what we're going to have to do to simplify this this limit is actually going to use a trigonometric identity. So we're going to need to use a trig identity to kind of rewrite this numerator of this fraction in the limit. And the identity that we're going to use is this one. So sine theta subtract sine phi is identical to, so the identity is 2 cos of a half theta plus phi multiplied by sine of a half theta subtract phi. So I'm not going to prove this identity in this video, but this is the identity that we're going to need. So if we go back to the previous page, so the x plus h here is going to correspond with the theta there, and the x there is going to correspond with the phi there. So yes, if we let theta equal x plus h, and we let phi equal x, then we're going to get the numerator within our limit. And if we just work out what theta plus phi is, well, that's going to be x plus h plus x. So that's going to be 2x plus h. And if we work out theta subtract phi, well, that's going to be x plus h take away x, which is just going to be h. And so therefore, from this, we know that half of theta plus phi is going to be x plus a half h. Sorry, this should be half of theta plus phi. And we know that a half of theta subtract phi is just going to be a half of h. So this is half of theta minus phi. So now we can just plug in the numbers into this identity. So now we know that sine of x plus h subtract sine of x is going to be identical to 2 lots of cos of x plus a half h multiplied with sine of a half h, just by using these results up there. Okay, great. So now we can plug this this numerator back into our limit up here. So we know that this is equal to the limit as h goes to 0 of 2 lots of cos x plus a half h multiplied by sine of a half h. And this is all divided by h. Okay, great. So we're now at this point here. And what I'm going to now do is actually rewrite this fraction in a different format. So if we notice, we've got a multiplication of 2 here. So multiplying a number by 2 is exactly identical to dividing a number by a half. So instead of having this this multiplied by 2 number up on the top of the fraction, what I'm going to do is actually divide, get rid of that times 2, and write a divide by 2 instead. So I'm just going to get rid of that times by 2 and put a divide by a half instead, because dividing by half is exactly the same as multiplying by 2. So then when we rewrite this in this new format, we're going to get the limit as h goes to 0 of cos of x plus a half h multiplied by sine of a half h, all divided by, so h times a half, well, that's going to be h over 2. And I'm just going to write it like this so that we've got the sine of h over 2 above the h over 2 in this fraction there, because that's exactly the same as this. Okay, great. So now we can actually split the limits into two different multiplications, or two different parts. So this limit is exactly the same. It's the limit as h goes to 0 of cos of x plus a half h multiplied by the limit as h goes to 0 of sine of a half h divided by a half h. Okay, great. So this first bit here, this first limit, so that's quite trivial. So as h gets closer and closer to 0, well, what's going to happen here? Well, this h up here is going to get closer and closer to 0. And if that gets closer and closer to 0, then h divided by 2 is obviously going to get closer and closer to 0. And so x plus h over 2 is going to get close to x. And so this first limit is just going to be cos of x. So we're going to get cos of x there, multiplied by the limit as h goes to 0 of sine of h over 2 divided by h over 2. Okay, great. So now we want to do this second limit. So to do this limit, we've just got to think about functions for a minute. So let's say we have two functions of x, so two functions f of x and g of x. And let's say that when x is small, so when x is a small number close to 0, let's say that f of x is approximately g of x. Then what does this mean? Well, this means that the limit as x goes to 0 of f of x divided by g of x, I should say here that g of x is a non-zero function, because otherwise if it was 0, then you can't divide by 0 in this fraction there, because that's impossible. But yeah, let's say we're going to divide f of x by g of x, and let's say we're going to take the limit as x gets close to 0, and they're both roughly the same as x is small. Well, this is just going to be the number 1, because we've got two functions which are pretty much the same when x is a small number, so when x is near 0. So when we divide those two numbers which are approximately the same, a number divided by the same number is the number 1, and so we're going to get a limit of 1. Now we're going to use this this kind of idea when we want to find this limit in this slide here. So this limit of sine of h over 2 divided by h over 2. So we know for small angle approximations, so when theta is small, so using small angle approximations, what we know is that sine theta is approximately theta. Okay, so now we can use this to help us out, because when h over 2 is small, that means that sine of h over 2 is about h over 2. Okay, so we've got two functions here, so sine of h over 2 and h over 2, so two functions of h which are approximately the same for small values of h, because when h over 2 is small, then that means that h is small. And so from there, what we can now deduce is that the limit as h goes to 0 of sine of h over 2 divided by h over 2, that must be 1, using this result over here. And so now what we've concluded is that this limit is 1, and so what we're going to get is that the derivative of sine of x is cos of x times by 1, and that's just cos of x. And so in conclusion then, when we differentiate sine of x with respect to x, the result is just cos of x. And that is our final result.